Okay, so right now we're going to be doing a reaction video to "Is Our Universe Inside a Black Hole?" theory. Video by Star Talk. So, are we in a black hole? It's a very good question. I would doubt that. Unless, like, if the theory says that the universe that we're imagining is the black hole. I would doubt because a black hole is just the negative. I would say I would explain it as a negative energy, right? So basically, everything that is positive, like light, is getting absorbed by the negative energy. That's the thing. It's attracted by it. So everything just goes into it and it just nullifies and it doesn't exist anymore. The things I might not actually, I don't know that much. I'm not an astrologist or a astronaut or working for NASA, so I don't know anything about astrology. But um, I just know that a black hole is just it's nothing. It's a ball of nothing. It's just nothing in the literal sense. It's a matter of nothing. It's a matter, daddy. um so and some people say there's probably a link to these black hole, like the white hole, right? So the black hole has a white hole, and there's like a pathway through it. Like, let's say you enter through the black hole and you end up in the white hole, but apparently, like, it just warps inside. And apparently, if a human goes into a black hole, it will just make you a spaghetti, and it would be very painful, by the way. But I think we're gonna die very quickly, depending on the size of the black hole. If it's a small black hole, like, let's say smaller than me, right? And I'm 5'11", um, I think it would be very painful, right? If a black hole is smaller than me, I think it would be very painful. But let's say if the black hole is literally two times the size of Earth, I don't think I'll be feeling much. I mean, unless we're imagining it as a gravitational pull, right? And I'm just getting pulled and I'm stretching slowly. Yes, that would be painful. But I think if a black hole literally size of a, let's say, a giant meteorite, like, let's say size of New York, I think if it just spawned out of nowhere, I would probably feel pain for like maximum 10 seconds and then I would die. Yeah. So, okay, enough talk. I know the video hasn't even started. Let's just get into it.
That our universe might exist inside a black hole? What's up with that? Well, let's back up for a moment, okay? And put
Oh my
some.
god. Did you see that? Oh my god, wait. Yo, it literally reacts when he talks. Wait, let me plug my mouse. Yo, that's so cool. What? Look at this.
Let's back up for a moment, okay? And put
Oh my
some
god, awesome.
base information on the table. A black hole is a region of space and time where the strength of gravity is so high that light has no path to get out of the object. All paths through space-time curve back in on itself. Normally we think of a hole as a hole in the floor, and you fall through, come out the other side. Except it's a three-dimensional hole. You can fall in any direction. That edge, beyond which there's no return, we call the event horizon. It's a horizon. The universe has a horizon too. It is a distance beyond which no information can reach us because the universe isn't old enough for light from anything beyond that horizon to have gotten here yet. By the way, the more mass is in a black hole, the bigger the black hole becomes. In fact, if you run the math on it, it's linear. So a black hole that's twice as massive as another one will be twice the diameter. 10 times as massive, the event horizon, which is our practical definition of the size of the black hole, will be 10 times as long. There's a cool exercise we do in graduate school. You can say, given the mass of the universe, how big would the black hole be that contained this much mass? It's the size of our universe to our horizon. And it's like, wait a minute, could we be one giant black hole? The average density of matter contained within the size of our cosmic horizon matches right on with what you'd get for a black hole.
Okay, I see what they're trying to do here, but I don't think so. And should we say like this horizon we cannot see through it because like it's not dense enough, and we cannot see through a black hole because it's so dense with matter that it's just pitch black, you know? Maybe that's what they're trying to say. But okay, let's establish this, right? A black hole is it's dark. Technically, if there's no light in space, you won't be able to see a black hole through it, right? But um what I'm trying to say is like what we see the black thing like it's just there's not nothing, right? It's just actually the black hole might be not a black hole. It's just it could just be a transparent hole and we just don't see it, right? But like we see a black hole because there's light refracting from it. Like let's say the sun gives out light and the light goes around it. That's how we see a black hole, right? But like I mean, it is possible if you think about it. Like, it could be like the black hole can be so dense, right? And the universe can be so dense that like we cannot see the like what's inside because it's it's so dense with matter and it's not large enough. So that's why we can see. Oh, okay, I see. But I don't know if that's what the theory says. But that's my own theory, maybe. But like, I see maybe the vision.
This size. That's intriguing. Maybe it's just a coincidence. What would it mean anyway for us to be inside a black hole? How would that work? Well, it turns out if you run the mathematics of Einstein's general theory of relativity into a black hole, it turns out a whole new space-time opens up on the other side. And you look behind you and the entire future history of the universe unfolds relative to your time frame. And so the universe you came from basically ends and a whole new universe opens up in front of you. Are we that universe that opened up in front of us? Okay, these are mind-bending questions. Well, there's recent research published that suggests that the contents of our universe has sort of a net rotation to it. Well, that'd be kind of weird. So in this study, it observed several hundred galaxies from the best observing directions you can come up with, which is above and below the plane of our Milky Way. And it noticed a net rotation of spiral galaxies in one direction versus the other. So if you look at spiral galaxies, if half of them sort of rotate like that and the other half rotate the opposite way, then they kind of cancel. But if most of them are rotating in the same sense, in the same direction, then that could hint that there's a net angular momentum of the entire universe. So what did they find? That 2/3 of the spiral galaxies measured rotated in the opposite direction as the Milky Way. So 2/3 is not 100%, but it's certainly more than half. We expect this to just be random. Normally in our lives, we think of something that rotates because some other force set it into motion to do so. And we look in the universe and everything is rotating, and then you ask, what force is making that happen? Turns out, all of our evidence suggests that when you make a galaxy or a star system or a star or a planet, there's some gas cloud that started it. If the gas cloud has any motion at all, the tiniest amount, as it collapses, its rotation will speed up. The gas cloud that was large, moving just a little, will move much faster as it gets smaller. And you know this already when you see ice skaters. When an ice skater spins and they want to spin faster, they start with their arms outstretched. And they have a certain rotation speed by virtue of that. As they bring their arms in, this is a phenomenon of physics called the conservation of angular momentum. If you start out large, slowly rotating, and now you're half the size, you're going to be rotating twice as fast. If you want 1/10 the size, you're going to be rotating 10 times as fast. Is that right? mv squared over r. Right. This is why...
Did you just do the calculations? What?
Everything in the universe has some kind of rotation because it's essentially impossible for any large gas cloud to not have motions within it to begin with. Often they're thermal motions. There's turbulence within the cloud before it sort of collapses to become something solid. Because of the turbulence within the clouds, there's no reason to think they would align with each other. They're each independent entities, so that when they collapse and the final product is spinning, there's no reason to think that the spin of this object is going to match up with the spin of an object over here. We have every reason to presume that there's no net spin direction of the universe or objects within it. So if we find and confirm that there is, we got to go back and ask, how could you get that, given our expectations of randomness? Well, that was linked to the idea that we might be in a black hole. Here's why. There's only two kinds of information you can obtain that are preserved inside that black hole. The mass, the total mass, and the angular momentum. Because anything falling in, if it falls in with a swirl, toilet bowl style, that angular momentum continues into the black hole itself. If there's a net angular momentum of the universe, where did it come from? It's not obvious that would come from a Big Bang, which is an explosion in all directions statistically evenly. What could it be? Could we be a black hole with a net angular momentum of stuff that spiraled into us? So that's where the black hole connects back to whether the universe is rotating. So I look forward to seeing whether this result is confirmed or falsified. It's an intriguing result, and the number of galaxies was not very large, just a few hundred, and there are billions of galaxies out there. So I'll reserve judgment until I see what others publish on this subject. Anyhow, that was a what's up with that on whether or not we are living in a black hole. And if we were, what difference does it make? But it's fun to talk about. Until next time, keep looking up.
If you love a good mystery.
Gosh. Yeah, that's it. That's the video. Wow. Okay. There's a lot of big words there. Kind of lost me there for a bit. But it's a crazy theory. And there's so many theories we could do almost for black holes. Like he explained, if a black hole has a beginning and an end, like a hole, right? Could it be like some pathways to like a alternative universe? Could it be like, you know, like some bridges between universes? Could be. It's an interesting thing to think about. But physics, honestly, is probably one of the harder subjects for me. Not a big fan of it. That's pretty much. So, thank you for watching this video, and we're going to be proceeding with the Valorant gameplay here.